Good afternoon, everyone. We will still wait for more participants to join us. So let's wait for another 2 minutes before we start our session. In the meantime, you can enjoy our video, and at the same time, you can also put your informations, in the chat, for where you are coming from. So you can be your name, your institution, and where you are coming from. Thank you.
As a researcher, you want to discover, build knowledge, and move research forward. But there are things that stand in your way. You need real-time access to the latest, most relevant content. But how do you find the right information? Who do you trust? 25 million researchers a month count on Science Direct to deliver the highest quality, full-text, scientific, technical, and health publications. Whether browsing generally or performing a focused search, our intuitive machine learning and data mining technology sifts through millions of journals and reference books to help you connect the dots and make decisions based on reliable, interdisciplinary research, saving researchers an average of over 47 minutes per day. How? With peer-reviewed research at your fingertips, including open access content, so you can achieve more breakthroughs. With alerts and personalized recommendations based on your signed-in activity, so you can uncover new research in less time. And with optimized HTML and PDF reading experiences, so you can discover, evaluate, and share content more effectively. Need to explore a novel research area? Use Science Direct topics to get up to speed. Want to make annotations or discuss your findings? Export articles using compatible tools like Mendeley. Outside your institution's IP range, get everything you need with remote access. With Science Direct.
Of course, welcome everyone from Indonesia, and I believe that some of you also coming from other countries. Welcome. There are a couple of announcements before we start this session. First, you can ask questions using the Q&A feature, and you can use English or you can use Bahasa Indonesia, and I'll be happy to translate your questions later on to our speaker. So please, once more, you can ask your questions later on using Q&A feature. Next, questions will be answered after the speaker's explanation. So we will have a specific time slot for the Q&A session. Information on the slides, recording, and also e-certificates will be provided at the end of the session. And if please do check your audio. If you are experiencing any difficulties, you can check your audio setting or try to log off and rejoin this session. This usually can solve the problem. Okay, so let's start for this afternoon. This is our agenda. So we will start first with webinar topic and also speaker's introduction. We'll go to the speaker session. We will have question and answer, and last, we will have closing and announcement as well. Okay, so let me quickly introduce our topic for this very special webinar. The title, Navigating the Publishing Process for High Quality Journals. We will have three main topics here. First is introduction to self-press and publishing opportunities, Indonesian's research output in self-press, and also our main topic, how to publish in high quality journals. Okay, and we have our speaker here with us, joining us from London office. Thank you so much. So we have Dr. Luke Bachelor. So let me quickly read his profile. So a chemist by training, Luke obtained his undergraduate degree from the University of Bristol and his PhD in organic chemistry from the University of Manchester. This was followed by postdoctoral work at Manchester and University of Paris, Sud 11, where he was part of an international collaboration using synthetic, spectroscopic, and computational methods to study molecular magnets. In 2012, Luke moved to Nature Communications, covering a range of topics in chemistry and material science. From 2017, he worked on the development of Nature Research Communication series of journals, also becoming chief editor at Communications Chemistry. Luke joined Cell Press in 2019 to launch Cell Reports Physical Science and is based in the London office. Okay, so we already have Luke with us joining from London. Hello, Luke. Good afternoon from
Hello,
Indonesia.
good afternoon, good morning from London, and good afternoon to everyone in Indonesia.
Okay, thank you so much, Luke, for joining and to become as our speaker for this session. So over to you, Luke, for our session this afternoon. Thank you.
So thank you for the kind introduction, Johan. And thank you to everyone in Indonesia for joining today. It's a real honor to get to speak to so many of you. I saw in the chat people were putting the institutions that they were from, and it seems that there's a real range of attendees from all over the country. So it's a real pleasure for me to speak to you. I realized that for a lot of people on the webinar today, English is not their first language. So I will try very hard to speak slowly and clearly. Also, as Johan mentioned, there'll be plenty of time for questions and answers. I've kind of blocked some time in my calendar after the talk, and I'd encourage you to ask any questions you have, either about things that we cover in the session today, or more generally about editorial or publishing processes. I'll be happy to try and answer whatever there is time for. Sorry, there we go. So first things first, I believe it was Independence Day in Indonesia earlier this week. So
sorry. Yeah. Okay. Now we can see your slide.
Yeah.
Thank you.
So I think there might be a slight delay. So happy Independence Day to everybody joining from Indonesia. I had a look on Wikipedia because, forgive my ignorance, I was not too sure about the things that happen on Independence Day in Indonesia, but it seems that there are many flag-raising ceremonies and as well some nice community events. So I know possibly this year it was a little bit more difficult than other years, but I hope you got to spend an enjoyable day with your families or your local community. So here's kind of a brief overview of what we'll be talking about. So the first part of the session will be introducing the CellPress portfolio. So some of you may be familiar with CellPress already. However, we've also grown a lot in recent years. So there might be some journals there that you're not so familiar with. So it will be a nice chance to introduce those. Also, Johan and his team have put together some information on the Indonesian research output in CellPress that I'll be briefly covering. And then the main part of the talk, and I think the thing that's probably the most useful for the majority of the attendees, is the last part where we talk about how to publish in high quality journals. And in that part of the talk, I'll cover manuscript preparation. So everything to think about before you submit your papers to a journal, and also the review process. So everything that happens after you've submitted your paper and really what we as editors do. Now, when I'm talking about this, obviously, all the examples I will be using will be from CellPress journals, and largely I'll be sort of, having to talk a little bit about my own expertise as a chemist, materials scientist, very much someone in the physical sciences. However, much of what I say, I would say almost all of it, in fact, would be relevant really for any scientific or academic discipline and would be relevant for any reputable publisher. So, I've worked at two of the major publishers, and the way that we do things, they're largely similar. So although this is a CellPress talk, and I hope that you consider submitting to CellPress journals, a lot of the information will be very valuable, I hope, for wherever you choose to submit your work. So let's begin with an introduction to CellPress. So where did it all begin? Well, Cell launched in 1974, and the original launch editor was Ben Lewin. Much like me, he was a former Nature chief editor as well. However, that's probably where the similarity ends. When CellPress launched, its mission statement was really to put science first. Whether it's the peer review process, the innovations in publishing, really we're designed to drive research forward, to lead with purpose, and to publish science that inspires. And this is carried through to Cell today, and the current editor-in-chief, John Pham, really embodies a lot of these values. But Cell, so Cell is a very highly regarded, well-known journal, publishing primarily in the life sciences. And over the recent years, the CellPress portfolio has grown. So forgive me, this is quite a busy slide, but I think the point is to show sort of the breadth of where we publish these days in CellPress. So, we continue to be a leader in life sciences publishing, have been since the the launch of Cell back in 45 years ago. During the 1990s and 2000s, Cell Press expanded into the life sciences with journals that some of you may be familiar with, such as Immunity, such as Neuron, Cell Metabolism, Cell Stem Cell, etc. So more community-focused life science journals. More recently, Cell Press expanded into the physical sciences in its first steps of becoming an all-science publisher. So moving away from publishing just in the biological and health sciences and, beginning to cover work in the physical sciences. So the first physical science journals were Chem and Joule, and more recently they were followed by Materi and Chem Catalysis, all of which I'll talk about shortly. Cell Press also now publishes in the environmental and sustainability sciences with journals such as One Earth, also run by one of my good friends out of the London office. And last year, Cell Press launched its expansion into the medical sciences with its flagship journal Med and open access journal Cell Reports Medicine. Other open access journals include the whole Cell Reports family. So this would be Cell Reports, launched in 2012, so going for nearly 10 years now. And then the sister journals of Cell Reports, one of which is my own journal. So this would include Cell Reports Physical Science, Cell Reports Medicine, and also Cell Reports Methods. Other parts of the open access portfolio include the interdisciplinary focused journal iScience, as well as the very broad journal Helion. Cell Press also publishes reviews journals, so a number of very successful journals, again, largely in the life sciences. So this would include things like Trends in Biotechnology, Trends in Cancer. And again, the Trends journals have also recently expanded into the physical sciences with the launch a couple of years ago of Trends in Chemistry. And then Cell Press also partners with a number of societies publishing journals such as the Biophysical Journal. As well as the journals that we publish, Cell Press also looks to add value where we can. So, not only are there the 50 journals that I've just covered, but we also have a wide array of learning resources hosted on the website. So these would include things like the Cell Press Picture Show, podcasts, mentoring and job corrections at the Cell Career Network, Cell Mentor, and also community outreach, which is done more face-to-face with things like Cell Symposia, lab links, webinars. Again, since the pandemic in 2020, we've been focusing a little bit more effort on the virtual events. However, in the future, obviously, we hope to move back to a hybrid or face-to-face model where we can. A lot of this content is freely available. In some cases, you may need to register, but it's very high value stuff, and I would recommend having a look at cell.com to see if any of these things are useful and interesting in your own research. So now I'm going to talk a little bit about some of the journals that we have. Largely, I'll be focusing on my own part of the portfolio. So this is the physical sciences. It's also an interesting part of the portfolio to talk about because it's, as we see, relatively new. So the physical sciences, top tier journals include Chem, Joule, and Materi. So each of these is a subject-specific journal looking to publish absolutely top work in the field and papers of which are interesting to, ideally, everyone in that community. So it might be, the chemistry journal, Chem, or the energy journal, Joule, or the materials science journal, Materi. Now, Chem launched in 2016, is led by Rob Eagling, who was formerly editor-in-chief of chemical science at the RSC. And, I don't want to get too hung up on metrics, but the impact factor and site score data are given for Chem. As you can see, the impact factor is 23 approximately. Joule was the next journal to launch. So much like Chem, publishing a range of content types of interest primarily to the energy research community. So, this goes from fundamental advances in battery science or photovoltaics through to policy papers on where to put wind farms. I mean, the key element of a Joule paper is that it's energy first. These are papers that really move the field of energy forwards. Again, you can see the enviable impact factor metrics for Joule. It's doing very well, and it's now in its 5th year. Matter launched in 2019. This is led by Steve Cranford, who joined straight from academia. So Philip, like Rob, came from the RSC. He was formerly editor of EES, whereas Steve Cranford, he joined from a research position, I think at Northeastern in the US, or possibly at Stanford. So Matter is a materials science journal. It's multidisciplinary, looking to publish transformative materials science. And, it understands that material science encompasses a range of topics, but also a range of, dimensionality. So, from nanoscale materials right up through to macro building materials. Matter also pioneered the MAP scale, which is a metric they provide for each of their papers, talking about how close to real world applicability does this work represent. Is this a very fundamental advance in lab-based materials development, or is this something that we're going to be able to build in a factory soon and will be in iPhones or in cars or in the wings of aeroplanes? Again, Matter attained its first partial impact factor this year, which was approximately 16. So as the physical sciences portfolio continues to expand, we also have another new journal which launched very recently this summer. This is Chem Catalysis. Unlike the other journals, it's a little bit more focused. So this is focused on catalysis. However, it's still a highly selective journal. So Ilaria, who was formerly an editor at Chem and has gone on to launch this journal, is looking to publish some of the top catalysis research out there. She has a focus on both fundamental and applied research, and is looking to sort of bridge the gap between the lab-based research, which takes place, and also sort of the perhaps less well represented work coming out of chemical engineering faculties or even industry. Again, as this is a new launch journal, it's still free to access and is for at least another nearly 9 months. So if you're interested in catalysis, I would strongly recommend that you have a look. I think issue 3 was out this week, and the first 3 issues have been incredibly strong. Really nice work, a great launch that Ilaria has done there. So my journal is Cell Reports Physical Science. So we are the premium open access journal in physical sciences within Cell Press. So the publishing model is slightly different, but the editorial models, not so much. We're still looking to publish cutting edge research. The scope of the journal is relatively broad in that we cover chemistry, materials science, energy science, and physics. So we hope to provide a home for sort of, work that's somewhat closely related to each other. We wouldn't really require the hugely broad advance that a journal like Chem would require. So it doesn't matter, for example, if one of our nanotechnology papers is only of interest to other people studying nanotechnology or that particular branch of nanotechnology. As long as the impact is sufficient, we're happy to consider the work. So yeah, we launched in January 2020, so we're into our 2nd year now. I think we published about 200 papers last year. We'll publish about 300 and something this year. And we've got some really nice stuff coming out. We had a great review yesterday on porous materials development, and very nice work as well on batteries discovery, both of which came from Oxford, which is why I noticed. So yeah, since we're open access, everything's free to read. So please do have a look at some of our content. So Trends in Chemistry, as I mentioned, is the first review or trends journal which publishes review content in the physical sciences. So the scope of the journal, primarily covers chemistry. The reviews are meant to be, digestible. They're meant to be good introductions to hot topics within the field. So these aren't the kind of, textbook-like reviews that you might see in a more traditional reviews journal. We'd hope that they'd be things that you could read and enjoy in one sitting, but will provide interesting opinions from leaders in the field. So yeah, One Earth, as I mentioned, is our sustainability journal. Its scope includes, looking at drivers and mechanisms of environmental change, looking at Earth systems, and considering transformative solutions. It publishes and brings together researchers from right across not just the physical sciences, but also the social sciences, the natural sciences, the political sciences. So Lewis is actually doing very interesting stuff with that journal. It has a lot of different content types. So while most of the more traditional physical sciences journals publish primarily either articles or reviews, Lewis commissions an awful lot of commentary, a lot of meta-analysis. So yeah, there are some, it's certainly worth having a look at. And then also, Cell Press. So we've covered briefly the life sciences. I've talked a lot about the physical sciences. And in 2020, Cell Press also launched journals in the medical sciences. So this was a pair of journals. So Med, which is one of the flagship journals, a sister to journals like Chem, Joule, Cell, run by Nicola Emambakus, looking to publish transformative evidence-based science across the clinical and translational research continuum. And again, like many of those journals, looking to bring together large and diverse audiences from translational, biotech, pharma, policy experts. And then this was launched alongside Cell Reports Medicine, which sits, I guess, in a similar position to my journal. So a premium open access journal publishing also cutting edge advances in the medical sciences, possibly not requiring quite the breadth of coverage that a paper of Med would cover, but still looking to publish very, very high impact work. And in fact, Cell Reports Medicine doesn't have an impact factor yet, but if you look at how the papers are performing, that journal's really, really doing good business, actually. So yeah, some of the journals I've mentioned have been open access. So, whether that's the Cell Reports journals. So they're really the premium open access journals that we have. They're our kind of OA flagship titles. As well as this, we have a number of other interdisciplinary gold open access journals, for example, iScience and Helium. And we partner with some societies to publish their OA journals, such as the Innovation or HGG Advances. And in fact, all the Cell Press journals, whether that's the OA journals or the subscription journals, do have open access options available. So all the subscription journals have a hybrid model for those of you that either wish to make your research open access or are compelled to do so by your funders. And here are some other examples of some of the journals that we have. So it's kind of the more advertorial part of the talk out of the way. So now I'm going to talk a little bit about Indonesian research output in Cell Press. So yeah, Johan and his team pulled this data together for me. So this is research from Indonesia published in Cell Press, and I assume it's been pulled from Scopus. So as you can see, since 2016, scholarly output from Indonesia includes 16 papers. Many of these are international collaborations. So this is papers where there are Indonesian authors working alongside authors from other parts of the world. These papers have been cited 418 times, and the average field-weighted citation impact is 3.3. So it's very good, very enviable. So for those of you not familiar with FWCI, really it's a metric which shows the relative citation of a paper compared to the average paper in that particular field. So it means that the 16 papers that have been published in Cell Press are 3 times more well cited than the average papers in those particular fields. And how does that stack up against other research communities? So for example, 3.3 is not dissimilar to Australia, 3.6, a very well-known and productive research community, and is also, largely in line or, above some of the other local research output. So where are these papers coming from? They're coming from a range of institutions across the country. and you can see how the individual papers have performed. So there was work from, I don't know, get the name of the institutions wrong, but from Institute Pertanian Bogor, been cited 100 times, which is, very impressive. As well as work from the Borneo Nature Foundation, University of Palangka Raya, Diponegoro, all of which have got FWCIs well over 5. So some high quality research coming out of the country. And here we can see sort of some of the authors involved. So clearly the top 3 authors were all on that very well cited paper. And then people who were who have done the work in Indonesia, but possibly since have moved to other institutes. And then how are self-press journals being used in Indonesia? So you can see popular journals in Indonesia include Current Biology, which is probably the most well-read. Not surprisingly, Cell, and then as well Cell Reports and many of the other life science journals. Some of the journals that I spoke about today, less well-read. In many cases, it's because they're newer. However, I believe there have also been some requests for some of the physical sciences titles from librarians and institutes in Indonesia. My journal, just 446 full article downloads. So as I said, it's free. Please do consider having a look at some of the CRPS papers. We publish some really good stuff. Advert for my own work there. Okay, so moving on to manuscript preparation. So, I've spoken a lot about many different journals, and all of these journals have different entry levels and different criteria for what they consider. But really, regardless of where you're publishing, you have to think about when is the correct time to write a paper. So, many of you will be researchers in physical or life science labs. You're working on ongoing topics. At some point, you'll have done a body of work that you think warrants publication. So ideally, you will have done something new. It won't just be, repetitive or incremental work. There'll be something challenging in it. So it'll be something that is, because it's difficult and interesting, will be of high interest to other people working in the field. And hopefully you'll have provided some solutions or at least some understanding of some difficult problems that are of relevance to the field. So if you can answer yes to some of these questions, I mean, ideally all of them, but that's not always the case, then it's probably a good time to start preparing your manuscripts. So picking the right journal. I mean, what you could do is you could submit all your papers to Cell, so that the best journal we have, and see if it got in. And then if it was rejected from Cell, you could then try, the next best journal and the next best journal until eventually you found a home. But it's probably not the most sensible strategy. So really, when picking a journal, you want to think about, who do I want to read my paper? This is the key thing, that the results you've done are broadcast to the people who are interested, who are going to care about them, who are likely to use them in the work, who are, for your own benefit, who are going to cite them, but really the people that need to know about the results know about those results. It might be that what you've done is so broad-reaching and so important that everybody should know about it, in which case you should consider a very, very broad journal, the likes of a Nature or a Science or so. But in many cases, the work probably, much as we all want to publish in those journals, much of the work that we do, certainly my own work when I was a researcher, it is a little bit more specialist. So I think it's probably, it makes sense to try and get into the best journal that you can, but to find an appropriate home for the work. So how do you do this? So you think about, what journals do I read? What journals do my colleagues publish in? If I attend a conference, where are people publishing the work that's similar to my work? So, you do a literature search, think about the work that's closely related, and maybe consider some of those journals. It's likely that things that you are citing in your paper will be, again, sort of similar levels and similar scope studies to your own study. So maybe consider somewhere that you cited a lot. Before you submit anything, obviously read the aims and scope page for the journal that you've selected. So make sure that you have well understood the scope of the journal and that your paper is a good fit. And then ideally, the right journal will have, editors and people involved who know the field, who know reviewers and who are able to, actively chase these reviewers, and who can professionally guide the process and help resolve any disputes. So again, I've spoken a lot about CellPress, and I would love it if you submitted all your work to CellPress journals. But I realise that there are other publishers out there. I think one thing that I would say is, as I mentioned at the beginning of the talk, much of what reputable publishers do, it's the same. So most reputable publishers will have editors that know what they're doing. They'll have good review process. They'll have good policies. They'll ensure research appropriate behaviour. There are less reputable or predatory publishers out there, so I would avoid publishing in those journals. I'm not going to obviously name any names during the talk. I think that's not useful. But before you submit anywhere, just double check the journal. So does it have people involved that you've heard of? Be they on the editorial board? Is it from a reputable publisher? So is it run by Elsevier or Springer Nature or a society that you trust? If so, it's probably fine. But if you're not sure, make sure that you do your due diligence before you submit. So why might you want to publish at CellPress? Just to take a step back, why would you want to publish in any high quality journal? Really, so that, as I mentioned before, so that it reaches the audience that you care about, so that it gets, well read, ultimately well cited. I think publishing in the right sort of journal can help you, get grants. It can help you be invited to talk at conferences. And CellPress has a lot of things to offer that I think will also help make the papers be as good as they can be. So in fact, all of our journals are run by full-time in-house professional editors. Now, lots of journals are run by academics, and it is simply a different model. It's not that one is better or worse than the other, but we, all of the editors on my team and all the editors that I work with, we've all worked in research, and now our job is to be professional editors. It means we have a very good reading of the field. We hopefully have a good insight to things that will be appropriate fits for our journals. And it means that we have plenty of time to, chase reviewers, to make sure that things get through the process quickly, to look at the minutiae of the papers that we're publishing once they're accepted, etc., etc. So we act as impartial surrogates for the broad readership of our journal. We're not sort of gatekeepers saying this is good science, this is bad science. What we're trying to do when identifying papers to send out to review is, considering, are these papers which are of potential interest to our readership? As I mentioned, we have time, so we can actively work with the authors. We can spend time making sure that we pick the right reviewers. We can hopefully make timely decisions. We aim to be very responsive and hospitable. So, if you have a paper under consideration at a CellPress journal, you can email the editor, the chief editor, and you'll probably get a response, relatively quickly. Certainly on my journal, we aim to get back to everybody for every question within a day. We'll maintain high scientific standards during the review process. That's, considering the behavior of both the reviewers and the authors to make the process as robust, but also as professional and pleasant as it can be. Many of our decisions are team-based editorial decisions. So, I consult with my editors on the decisions that I make, considering both my own research expertise and theirs, and as well as, broader understanding that we've developed over the times that we've been handling lots of papers. We listen to the communities that we serve. Where they want, we experiment and innovate. So whether this is considering, the transparent peer review pilots done at journals like Cell Systems, whether it is looking at offsetting the carbon for papers published at One Earth, we try to do things a little bit differently, and try to sort of lead rather than follow the publishing industry. We have a reputation for rigor, and we're very good at post-publication promotion. So this will be, once your papers are accepted, we'll work with our press or marketing teams to ensure that it's widely disseminated on social media, in the general press, if it's appropriate to do so. May, pardon me, contact authors for interviews, etc. So what makes a good manuscript? So obviously the science within the paper should be exciting. And But that's kind of a little bit separate to the manuscript. The manuscript itself should be written in a way so that what you as the author think is exciting and interesting about the work is conveyed to the reader by the time that they've finished reading the paper. So you identify the topic that you're working on, you identify the gap in the knowledge, and then you show through your results and discussion that you've addressed this and that you've moved the field forward. And hopefully it's written in a way that this is very, very clear for people to understand and to follow. And that when, readers finish with your paper, they understand why you did the work and why it was exciting and how they can use it in their own work. So some general points about paper writing. I'll talk about each of these issues in more detail in a moment. But first of all, very important are the title and the abstract. Secondly, as I've alluded to already, think about the story of your paper. So, I think, and I was guilty of this too when I was a researcher, in the beginning of your career, you want to include all the experiments you've done, all the data to show how hard you've worked. But that's not always the best thing. What you should think about is, what is the story that you're telling with this paper? How have you advanced the field? Either, very, very broadly or more narrowly. But you should provide the data and experiments required to sort of underline this point and to make this argument. And you present the data in such a way that it moves the argument forward, not necessarily in the order that you actually collected the data. You might want to make use of summary statements throughout the paper. So to, underscore the central point of a paragraph or a subsection to keep the argument clear and to keep it moving forward. And then before you submit the paper, you might want to sort of get a pre-review from colleagues that you trust. So, before submitting it to a journal, ask some colleagues to read it for you. And this, partially will be to make sure that there aren't any, silly spelling or grammar errors or minor things like this. But more importantly, it will be to look at the flow of the logic within the paper. So, will someone perhaps less familiar with the work than you understand the points that you're making within the argument? Will they understand how you've moved the field forward? And will they agree that the experiments that you've shown support the conclusions? I mean, in fact, English, of course, is important in these things. The reviewers may speak English as a first language, but may not. The readers, certainly will be a range of people from around the world. So if English is your second language, then again, you might at this stage want to ask a native speaker to check, or there are also, many language editing services available. Alongside your paper, you'll want to include a cover letter. So a cover letter is important. It's your chance to, speak directly to the editor of the journal, but it's not the be all and end all. I mean, everyone that's, that's doing a professional job will read all of your paper before making any decisions. However, they will also read the cover letter. So it's a chance to speak more conversationally, perhaps to raise things that you wouldn't necessarily put in the paper, but to highlight why you think the work is not only exciting, but is a good fit for the journal that you've submitted to. Now, I've worked for journals called Nature Communications, Communications Chemistry, and Cell Reports Physical Science. I've received cover letters addressed to science, addressed to Angewandte Chemie, addressed to advanced materials, addressed to JAX. So I would make sure, editors, aren't totally naive. They realize that papers get submitted to many journals. But if you're submitting to a journal, which is not the first journal that you've submitted the paper to, make sure that you update the cover letter. Again, it's not going to, no one's going to reject your paper because of this, but I think it shows attention to detail. So yeah, within the cover letter, you can provide any additional background, and you can, speak conversationally about why you've addressed this particular point or why you think it's important. So the kind of conversations that you might have if you bumped into me at a conference, if you really loved the work and you think it's, some of the best stuff to come out of your lab, you should tell me this and tell me why. It's also useful to let the editors know if there are any controversies in the field. Are there any particular competitions which might put time constraints on the work or might affect our choice of reviewers? And it's also your chance to sort of suggest and exclude reviewers. Now, by and large, we probably won't just use the reviewers that you suggest, because of, we need to ensure that there aren't excessive conflicts of interest. But if you need to exclude any reviewers, we probably will honour that, as long as you're excluding a reasonable number. So it might be 2 or 3 because of academic competition or because of even personal issues, but we probably wouldn't allow you to exclude, for example, all the reviewers from a given country, or more than 4 or 5 individuals. Things probably not to include are the abstract, a list of past accomplishments, including prizes or how much money you've got or where you've presented the work, soft feedback that you've had from other people in the field. I mean, these are kind of unverifiable things and not particularly useful. Okay, so manuscript preparation. So throughout the work, when you're writing, you should always think about, are you using proper manuscript language? So this is both using, clear and correct English, but also writing in short sentences. So the point of the paper, as I sort of mentioned already, it's to convey one idea. What is the idea of the paper? What have you shown? And you want the reader at the end to understand really that one thing. All the results and discussion and additional data is to support the one thing that you've shown. The point of the paper isn't to show off how clever you are or to show off how good your English is. So I would always recommend using, to the point, short, clear sentences rather than long, rambling, multi-point, more floral language. If you want any advice about particular paper structure, which will vary from journal to journal, of course, look at the guide to authors while writing. And if you're unsure about the ability of yourself or your co-authors in terms of your English writing, then ask a colleague to have a look at it before you submit, or again use a language editing service. We won't reject papers because the English is bad, by the way. I've published plenty of papers where the first draft has been written with quite poor English, but it does make things more difficult for the editors to understand the bottom line of the paper, and it potentially makes things more difficult for the reviewers to understand. So, we're not being punitive by suggesting that you work hard on the English, but I think papers do have a better chance of making it through if the English is clear. So the paper pyramid. When you're writing papers, this is how you perhaps think about them. Again, it's certainly how I thought about them. Most of what you write is the main text. It's the introduction, the results, the discussion, the methods. You might spend a long time putting together your experimental section and formatting your references. You might spend some time on the abstracts if you're particularly diligent, but a lot of people, throw the abstracts on right at the last minute. And the title, who knows how long people spend on the title, but it's not really, normally papers are written by more than one person, and normally the title is kind of something that's agreed on at the end. So I think it's understandable why authors think about papers these ways. Again, certainly it's the way that I did when I was working in the lab. However, the reader's perspective is very, very different. The reader, is shown a huge amount of information every day, whether they're looking at table of contents emails, which are sent to them by journals, whether they're flicking through, Scopus or Web of Science or Google Scholar to look for papers to read, whether they are looking through the issue of their most, the recent issue of their favorite journal. There's so much research out there. I think global research output is doubling every, one of the marketing people probably know the right answer, but at least every 10 years, probably faster. So we don't all have time to read every paper. What people do is they scan titles and possibly abstracts, and then they decide whether or not to read the main text. So I'm not saying here that the main text is not important. Of course it is. But I think all of us could probably do to think more about the titles that we use for papers and the abstracts, because really these are the advertisements for your paper, and these are what will get people to read the paper and then use your work and cite your work. So an effective title, what should it be? It should be succinct, it should describe the key content, the main point should be clear, and you should avoid obscure abbreviations. So again, my background is chemistry. Some of the molecules that I worked on, they were huge transition metal complexes with many ligands. To write down the name of the molecule would take 2 lines. But sometimes I'll be tempted to do so, but that's not useful. That's not useful for the reader, and it's unlikely to make people stop and read your paper against the ocean of other papers out there. So, I've spoken many times already about the importance of having a single point in your paper. Once you've realized what the single point that you're making is, make sure that you include that in the title. So really the title should say exactly what you've done, not what system you've worked on necessarily, not what methods you've used, but what have you found out? What are you showing? How have you moved the field forward? And it should do so ideally in as fewer words as possible. So next is the importance of a clear abstract. So, you might choose to publish your work in an open access journal, or you might choose to publish in a subscription journal, which, maybe behind a paywall. However, abstracts are pretty much, most abstracts are listed in abstracting services, and almost all abstracts are in front of paywalls. So again, this means that when looking through the literature and deciding what to read, if a reader's attention is grabbed by the title, they will probably be able to find the abstract, and they'll be able to read that and then again decide whether or not to read your paper in more detail. So it should be interesting and understandable. It's your chance to sell the work to the reader. But by sell, I mean very, very clearly describe what you've done and why that's important. I don't mean use excessive hype. So, the number of abstracts that I see every day that talk about the high novelty of the work, or talk about holy grails, or talk about paradigm shifts, these are not useful things. I think the best abstracts are the ones that really quantify an advance that's been made. So really, most abstracts, if you read any abstracts from good journals, you can break them down into probably 4 sections. Each section is typically a pair of sentences. So the first section, the first 2 sentences, should be the introduction to the field. So what is the area that this paper's on? And it can start very, very broad and become more narrow. And maybe why is that area important? Why should anybody care about it, not just the potential readers of the paper? The next pair of sentences is normally identifying the literature gap. So showing, within this field, people have done X, but people don't understand why. Or, within this field, the current best performing device has performance this, and it would be good to make it perform better for reasons Z. So start off very broad with the first 2 sentences, and then become more narrow and identify the literature gap with the next 2 sentences. The next 2 sentences are probably the most important, and normally they would start with something like, here we show. And this is where you describe the bottom line finding of your paper. So the 1 or 2 sentences saying exactly what you've done, and using using data and appropriate levels of quantization where possible. Then you should show, then the final 2 sentences kind of tie your results back to the introductory sentences in the knowledge gap. So how has what you've shown addressed the question that you presented in the knowledge gap? And finally, how has this helped to move the field forwards? And I think using this kind of broad, narrow, broad strategy makes for a very, very clear abstract, and will encourage people to read your paper if it's an area that they are interested in. And I think this sort of strategy you can then see emulated throughout the paper. So, the introduction really is an extended version of those first 4 sentences. You introduce the field, you talk about why it's important, you talk about what leaders in the field have done, you identify where the knowledge gap is. That's sort of a general introduction. The results, you talk very clearly about what you've done, showing your data. And then the discussion, you talk about how this ties to the introduction. What does it mean? How has it moved the field forward? So that, the abstract really should be kind of the paper in single paragraph form, but the general structure applies throughout the work. So really, with that in mind, this is how we think about the introductions. So where does the field stand? What is the current state of the art in the field? You should highlight appropriate levels of referencing here to sort of show that you've done your due diligence, to show that you understand the field. You should cite the important papers. So it might be that there are very, very important papers that everybody cites. Probably you should cite them. But it might also be, that there's more specialist papers that are more closely related to the particular knowledge gap that you're working on, and you should cite those too. It might be that some of these papers have come from your lab, and it's fine to self-cite, but I would avoid excessive self-citation at all costs. So this is a thing that, reviewers and editors will call out. So if your work is relevant, please cite it. If it's relevant, this is not an appropriate place to shoehorn citations to your work in. Make sure that you represent the field appropriately. If it is only your lab that's working on a particular problem, it might suggest that work is highly specialist. So again, this would perhaps go against you for certain more selective journals. So I think it's a good idea to show that there are a wide community of people working on the problems that you're addressing. Then finally, within the introduction, you might want to identify potential solutions and, current limitations to the work. So, the knowledge gap that I've spoken about. So the next section is the results section. This should be clear and easy to understand. Normally, it should be broken up, into subsections, which show how the argument works. So it shows, if you are making a device, it might be that the first section is the synthesis and fabrication of the materials. It might be that the second section is the analysis of the individual components' performance. And it might be that the final section of the results is the analysis of the device performance. This will vary from field to field enormously. But I think the results should be set out in a logical manner with judicious use of subheadings, so that anyone kind of skimming through the paper, which realistically is how a lot of people will read your work, can follow the argument that you've made. If you have any unexpected findings, they should certainly be brought to the forefront, not buried. And much work that is done has the scope to provide statistical analysis. So certainly much work in the life sciences, certainly more and more work in device physics, for example. I think if you've made 20 devices, you should report the data for all 20 and do statistical analysis rather than reporting just champion values. The data that you're providing should be included in the form of high quality illustrations and figures. We can talk about those a little bit more in a moment. So data preparation. So you should use appropriate color to make your data as clear as possible. But when do so, bear in mind that some of your readers might be colorblind. So I tend to recommend avoiding overuse of, for example, green and red together, which can be difficult for some people to read. Lots of the data that we present in the papers, and certainly the data that I see in the papers that I read all day, is in the form of graphs. So when plotting any graph, think about how much data are you putting on that graph. I know that you don't want papers to be sprawling huge beasts with more figures than are necessary, but I would avoid trying to cram too much data onto any one particular graph. Also, I would say, in my experience, two-dimensional graphs are far superior to three-dimensional graphs. It's very rare that a three-dimensional graph is necessary, and I would say it's entirely rare that it's more readable and more easy to understand than a series of two-dimensional graphs. If you are putting more than one data set on a particular graph, of course, make sure that you use different symbols and the two data sets are clearly delineated from one another. Also, I would avoid the temptation to put more panels than is necessary in any one figure. Much like the subsections of the results, the figures should make a clear point, which is moving the argument that you're making forward. So, if you have some characterization data, it makes sense to put that together. If you have some particular analysis, it makes sense to put that together. If you have some particular performance data, it makes sense to put that together. But I think if you start combining analysis and characterization, or characterization and performance in a particular field, in a particular figure, it can become very difficult for the readers to understand and to follow. All figures should also have, brief headings as well as clear legends explaining what's going on. So it should be possible for a reader to skim through the paper, really just looking at the figures, and at least understand what is the data that's been presented in this paper. You know, the legends themselves should provide enough information so that in isolation, it's clear what a figure is showing. And the subheading, the titles for the figures should, you know, give the overarching story that that particular figure is telling. And again, by reading the abstract, skimming the figures, you should have a pretty good idea of what the paper's showing. So finally, the discussion is where you tie everything together. So you do your analysis of the results. What do the results mean? And how do these correspond to the the data that you've shown, and how do they compare with other literature? So you should compare, you know, what you've shown with the literature which is out there. I'd avoid, you know, I think at this point as well, there might be analysis which is done on, for example, mechanisms at play. How is what you've shown working? And I think it's okay in the discussion at some points to be speculative. But I think if you are being speculative, make it very, very clear that that's the case. So, you know, I wouldn't suggest things which you don't have evidence for in the results as fact. I think it's okay to say, look, this is what we've done. This is what we understand about what we've done. These are the limitations of this understanding. And this is what we're going to do in the future to understand it more. I think that can be very useful to the reader. And where possible, you know, throughout you should use quantitative language. So if your data show something which performs twice as well as the next best example in the literature, then you should say that. You shouldn't say it performs exceptionally well. You say it performs twice as well, because again, this is more meaningful to a reader. And it also, you know, all papers are just points in time. Whatever you've presented will not always be novel, and it will not always be the best. There will be more novel and better work in the future. But I think if you quantify it, then the paper becomes more useful further down the line. So the references, I've spoken quite a bit about the references already in terms of selection. So make sure that you reflect where the field is. Make sure that you use as many references as you need to provide a thorough literature review and to identify, you know, knowledge gaps within the field. But you don't need to include, you know, many references just for the sake of it. You should ensure that you avoid excessive citations, or avoid excessive citations of publications from one region. So, I mean, there are some fields that are, you know, more well studied in certain parts of the world than others, but by and large, most science is a global international enterprise. So make sure that you're trying to reflect this in how you cite work. And finally, you know, as far as you can, make sure that you conform strictly to the style given in the guide for authors for the particular journal that you're submitting to. So different journals will use different referencing styles to some extent. And I mean, a lot of this will be tidied up in production. However, it makes things easy for the reviewers if they see references styled in a way that they're expecting to. If I had to give one like hot tip for providing references, make sure that you provide the names of the articles that you include in the reference list. Some authors fail to do so, and it can make things difficult for the reviewers. There's the Acknowledgement Section. So this is a chance for you to ensure that those who helped in the research are appropriately recognised. So this might be any advisors or undergraduates who contributed in some way but not sufficiently to be authors on the paper. In many cases, it will be financial supporters and funding bodies. It might be proofreaders, or it might be suppliers or individuals that have donated materials or lab time or facility space. I'd avoid any personal acknowledgements. Most journals don't allow, for example, dedications to universities or individuals or these kind of things. So the editor, so that's, you know, this is how to prepare a paper. So how to think about when to write a paper, the things to include, the way to construct a paper so that a very, very clear argument is made. What happens to that paper once it's submitted to a journal? So again, the manuscript journey is largely the same at most journals. So papers are submitted through some kind of manuscript submission system. And once they've passed the sort of preliminary, checks to make sure that the file's open and that all the figures are there, there's an editorial review. So here the editors decide, are we going to send this paper out to review or are we going to reject it? Now, the rejection rates vary hugely from journal to journal. A journal such as my own probably aims to send out maybe 40% of the papers that we get. However, a journal like Joule might only be sending out maybe, 5% of the papers that we get, and far more selective. So, if you are rejected, bear in mind you'll be in good company. I wouldn't take it too much to heart. Most researchers have to go through a number of journals to find the appropriate home for their work. However, publishers try to make this as easy as possible for them these days. So if the papers that are sent to review, the editors will identify and recruit reviewers. They will wait for those reviewers to submit their reports, which hopefully will take, 10 days, but in the current climate can take a lot longer sometimes. And once the editors have received enough advice from the reviewers, which will normally be 2, 3, 4, if necessary, reports, they'll make a second editorial decision. Now, it might be that the reviewers have identified either fundamental or technical issues that the editor doesn't think can be addressed or that undermine the novelty of the work. The paper might be rejected post-review. Or it might be accepted. It might be that in some cases, all the reviewers say, this is great, there's nothing to change, accept it. In most cases, the reviewers have identified things that the authors need to go and correct, or they've identified places where further data or analysis are required, or discussion needs modifying. So the editors will invite the revision. So the paper's sent back to the authors for more work. This then comes back into the journal and the editors decide, okay, does this need to be seen by the reviewers again? If there's, further technical data, or if there were particularly controversial points, it might be that it's sent back to the reviewers. Or it might be, if the revisions were more minor in nature, that the editor themselves can say, okay, the authors have done everything that we've asked, and the paper can be sort of accepted at that stage without further review. Once papers are accepted, they're sent through, for final editing, production, and publication. So what do the editors do exactly? So, for each paper, there'll typically be one editor assigned. That'll be the primary handling paper for that paper, the primary handling editor for that paper. Probably it will be the person with the most relevant experience at that journal, which might, come from their research experience, or it might come from experience they developed over their time as an editor. So, during my career, I've published hundreds of papers on battery science, but as a researcher, I never worked on batteries. This is kind of knowledge that I've developed within the industry. The editor, that will be the person responsible for the decision, but will probably discuss it with their editorial colleagues when necessary. So what the editor's thinking about is, what's the point that these authors are making, and how is that an advance over the published literature? And is that enough of an advance for a journal like ours? And that won't always be the same answer depending on the journal. And they decide whether or not to, send the paper out to review. And if the paper is sent out to review, they manage the review process. So, selecting and guiding the reviewers. And also we do quite a lot of work at publication on working with the authors to make the paper as clear and as accessible as possible, and also to ensure that it's well promoted once it's out there. So the outcome of the editorial evaluation. So yeah, the initial evaluation, we decide as editors whether to send the paper out to review. If we decide not to, then it will be returned to the authors. We try to do this as quickly as possible. So at my journal, we do this within 3 days. Other journals, it can vary depending on editorial workload and things. If we do reject things, we try to provide some explanation as to why we don't think it's likely to be a good candidate for publication at that journal. If we do decide to send it out to review, then we begin identifying reviewers. And as I mentioned, we take into consideration the author's suggestions and exclusions, but probably won't use all the people that you've suggested. We do quite a lot of conflicts of interest checking before we assign any reviewers. So we're not going to use people at the same institutes. We're unlikely to use, former supervisors or students. We're unlikely to use, regular co-authors. These are the kind of things that we check for. So what do we ask the reviewers to evaluate? We ask them to look at the technical quality of the data, the degree to which the data support the conclusions, and to feedback on the level of the interest, both for those working in the field and more broadly. And each reviewer assesses the paper from a different standpoint, so we try to use a range of people. Now, this might be in terms of seniority. So obviously, a very established senior professor will have quite a different view of the field to a postdoc. Not to say that they both can't provide valuable critique, but we'll probably use a range of people with different levels of seniority. Also, more importantly, we'll think about what are the different points within the paper. What are the areas of expertise that we need to cover? So, is there a computational section? Is there perhaps some animal work? Is there a particular technique that's used? And we'll ensure that we have enough reviewers to cover each of these areas. So this is why we end up with 3 or maybe 4 reviewers for a more complex paper. And as I said, we will honour reviewer exclusions. Briefly, what are the responsibilities of a reviewer? Partly to know when not to review. So as I said, we will do conflicts of interest checking, but we don't catch everything. I mean, I know of pairs of researchers who are married to each other, but who've never published together. So unless you know that, you can't always catch these things. So are you close contact to the person who's the author of the paper? Have you published things together that have maybe been missed by the editors? Have you spent time working on a grant? You share students? All these things. If you think you can't provide a unconflicted review, then let the editor know and just decline the invitation. In some cases, it might be that you maybe published a paper together 8 years ago, and you feel that you can provide a clear report, and I think that's perfectly reasonable. Again, it's normally a good idea to at least let the editor know that there's this potential for conflicts of interest, but I think as long as people are transparent about this, then normally we can move forward. As a reviewer, we'd expect you to behave, confidentially, so not to tell people about what you're reviewing, and to use it as an opportunity for training and sharing in the lab. So it might be that you review, in collaboration with one of your grad students or postdocs. Again, this is all sort of perfectly reasonable. If you want to, seek advice from another colleague, pardon me, on a specific point, this can be fine, but generally it's a good idea to let the editor know. We ask our reviewers to be constructive, both in the comments that they raise, but also in the tone. And ideally to be timely. So if you can do it fast, that's great. If you can't, then either say no, or if you think you will need an extension, this is normally okay, but it's a good idea to let the editors know. And finally, we'd expect our reviewers to commit to reviewing the revised paper. Excuse me. So the editorial decision post-review. So the editor then brings together all the advice they've been given by the reviewers, as well as their own preliminary assessment and their reassessment, taking on board the comments of the reviewers. And we think about, what has been asked. We think, are the things that have been asked addressable? Have the reviewers asked for things that would strengthen the central message of the paper, or have they asked for things that would just be nice to have? What's the overall level of enthusiasm of reviewers? We're not really counting votes here. So if 2 people say publish and 1 says don't publish, we don't say, okay, let's publish. We think about what the sort of strengths and weaknesses of the different arguments made by the reviewers. We tie all this together, along with our own kind of, understanding and experience of how papers fare post-review. And we come up with a decision about whether to allow the authors to revise or whether we reject the paper. Pardon me. In most cases, we do like to look for ways forward, but we want these to be things that we think are possible and things that will improve the work. So really, this is just, reiterating what I mentioned in the previous slide. So, when we make a decision, we think about how close is the paper to be, acceptable. Are there things that we could ask the authors to do that we could check ourselves? If it's a more complicated, revision, we will ask the authors to sort of respond to everything where possible. Or if there's things that we think that the authors, aren't able to do, or if there's things that the authors think they don't need to do, then we wouldn't encourage them necessarily to respond to everything. We kind of come up with a revision plan with the authors themselves, and this is how we move forward. So upon receiving an invitation to revise, so first of all, normally this will be in the form of a revised decision. It will, some authors find this quite difficult because there will be, more or less comments, many of which will be critical about your paper. But the positive thing is that the editor has allowed you to revise. So first of all, carefully read the letter and decide whether the experiments can be completed in the time frame indicated. Sorry, I've just got something in my throat. Bear with me one moment. So if you can, that's great. If you can do the extra data, if you can provide the extra data and the extra analysis, then just go ahead and get on with the revisions. It might be that the reviewers have asked for some things that simply can't be done or can't be done within a time frame. And if that's the case, it's a good idea to let the editor know early and to discuss with the editor. Perhaps you can come up with alternative experiments for analysis that can address the reviewer's concerns, or perhaps you could modify the claims of the paper slightly. Both of these are routes that I've taken to sort of move papers through when some experiments have been not doable. So then when revising, obviously make your revision count. So, come up with the revision plan before you submit the revised paper. And then alongside the revised paper, make sure you include a detailed point-by-point letter addressing the reviewer's concerns. So the best formatted ones I see are kind of broken up into 3 sections. So for each point, it's a good idea to include word for word the reviewer's comment so that it's clear that you're being transparent in your response. The second section addressing each point should be your response. Either yes, you agree with the reviewer and this is what you'll do, or no, you don't agree with the reviewer because of this, maybe including some of the literature references. And then finally, if you've made any changes in the paper, the third section should be highlighting this is how we changed paragraph X. See the revised version here. What you're trying to do is you're trying to make it very, very easy for the reviewer to go through your response and to say, okay, yes, 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 yes. For them to see that you've engaged with all their arguments and for them not to raise any further concerns. Sometimes further concerns will be raised, but if you try to make things as easy for the reviewers as possible, you can hopefully make things easy for yourself. Now, not all papers will make it through and some papers will be rejected. But at this point, it might be possible to transfer to another journal within the portfolio. In many cases, this will be recommended by the handling your paper. But if it's not, and it's something that you want to consider, of course, you can also reach out. So as an author, you can reach out to the editor of the sort of, next journal in the portfolio you'd like to consider. You can say, my paper's been reviewed at this journal. These were the points. They decided not to move forward at journal X, but we think we can make these changes and the paper will be appropriate for journal Y. And these are conversations that the editors at both journals are very happy to have. So again, in some cases, your paper will be rejected and you might want to consider appealing. Now, if you do appeal, the best thing to do is to provide, much like with the revision, a clear point-by-point to the reviewer's concerns. The best appeals do provide additional data to address the technical issues. And if there are any conceptions that the reviewers have potentially misunderstood any of the technical findings or the significance of the work, then they also include, good literature examples of why the work is important or why it's sound. Less good examples of appeals include, verbatim attacks on the editor or the reviewers, or, simply disagreeing. So I think the more positive and data-filled you can make your appeals, the more likely they are to be successful. However, bearing in mind that most appeals aren't successful, so I think probably we overturn rejection decisions on maybe a quarter of the appeals that we receive. So it can be worthwhile doing if you think you can honestly address the technical concerns of the reviewers. However, if a number of reviewers just say, I don't think this paper is appropriate for journal X, you're probably less likely to be able to overturn those type of recommendations. In many cases, appeals will be handled again by the editor, and in many cases, they'll go back to the original reviewers. So yeah, we spoke a little bit about the transfer process already. So this is something that many publishers offer. So yeah, if you choose to transfer your paper, it can be transferred either pre or post review. The fact that your paper has been rejected by one journal within the portfolio will not prejudice the decision at the second journal. In fact, in many cases, the editors at both journals will have a good idea of each other's editorial criteria. And so I receive a lot of papers at my journal from Chem, for example. And the editors at Chem well understand the sorts of papers that we're looking for. And so if they recommend a paper from Chem for CRPS, there's actually a relatively high and a proportionally higher chance that the paper will ultimately be accepted at our journal. If the paper's been reviewed at one of the journals and is transferred, then the reviewer identities and reports will be brought across to the new journal. And typically you will have a chance to revise your paper sort of during the transfer step. If you ever have any questions about this, then contact editors at either the recipient or the donor journal. And finally, after acceptance, this is when the authors and the editors celebrate. Everybody's happy that the work is going to be out there. There are, some final things to do in terms of organizing files, clearly following the instructions given by the editors or the operational team, copy editing and page layout, author publication. And then ultimately, the editors will work with you to make sure that your paper is promoted as widely as possible, either through preview articles, social media, press releases, etc. So that's really the editorial journey. And I hope what I've spoken to you about has been useful. Apologize for coughing for the last 10 minutes. I've got a bit of a dry throat from speaking so much. For more information about any of our journals, check out cell.com. And if you want to recommend us to your librarians, please visit cell.com/recommend. And thank you very much for attending. It's been an honor to speak to you. And now I'm happy to take any questions.
Okay, thank you so much, Luke, for such a detailed explanations from introducing Self-Press to Indonesians audience, and also your best practices in writing and also publishing research manuscript, especially for high quality journals. So if we look at the Q&A, we have around 100 something questions, which will be impossible for us to answer all, but I already point out some questions which I think will be very interesting for us to discuss. Yep. Okay, so there's one question. So let me read through the questions and from this Q&A. Yeah? And for other participants, if you haven't put your questions in the Q&A, feel free to do so. Yeah, because we are now coming to the Q&A section. Yeah. Okay, so the first question is, this is regarding the numbers of authors. So do you think that there is any maximum number of authors that can be accepted for any journal?
No, I mean, I don't think there's a maximum number. I think we have to think about the appropriateness of the authorship. So have all the people in the author list contributed to the paper in a meaningful way? So I think, in some cases there will be, many different techniques, each with several people working on them, and all these people will perhaps have done enough to contribute to the paper and to be considered as authors. But what all journals want to avoid is kind of, ghost authorship or controversial authorship, where people are included for the sake of it for their own, publication records. So I think no. Look, most journals, certainly mine, all the Self-Press journals look for author contribution statements. So we will want the authors on the paper to have contributed in a meaningful way. But if people have done so, then sure, it's appropriate for them to be authors. So yeah, it's not really the number, it's about what the people have done. Okay, and usually journals will ask their contribution. Yeah, there will be a part in your article that state the contribution of each author. Thank you for that. No. Okay, so the next question. Yeah, have you ever created like a special issue in any Self-Press or any journals in Self-Press collection? And if you create any special issue, should the article have a specific requirement to be published in this special issue? So some journals run a lot of special issues. So I think the Self-Press journal, which is looking the most at sort of the special issue model, is iScience. So I don't work for iScience, so I can't tell you like too much detail about it, but I know that they have a number of ongoing special issues run in collaboration with various experts from the field, and they hope to sort of bring together similar studies and create these special issues that are of use to the communities that they're aimed at. So I think, some of the work that goes into these special issues is invited, and some of it is directly contributed. I think, if work is invited to a special issue, it still has to go through all the editorial and reviewer checks that any of our papers do. So the fact that work's been invited to a special issue doesn't guarantee that it will be published. However, if it makes it through all those checks and it's deemed appropriate for the journal, then yes, I think by and large it will be published and it will be associated with that special issue. But I think, iScience tends to lead the way with special issues. We have one coming out next year, but it's very small, it's very heavily curated, so perhaps not the type of special issue that your questioner is alluding to. But yes, some cell press journals, particularly iScience, do have them, but the treatment of the papers is identical for any other paper, really. The papers still need to be appropriate for the journal and correct in all the ways that we need them to be correct.
Okay, thank you for that very complete explanation. So there's another questions about gold and green open access. So are you your journal itself, is it gold open access, is it green, and can you tell us what's the difference? Let's say, is there any difference in the speed of reviewing or something else?
Okay, cool. Yeah. So, the gold and green open access are kind of publisher speak for different publishing models. So a gold open access journal is one where the author pays an APC and the published article is made freely available, normally with a Creative Commons license at the point of publication. So my journal is a gold open access journal. The other Cell Reports journals, iScience, Helion, some of the partner journals, these are all gold journals. So there are APCs associated with publication, but the papers are made freely available as soon as they're published. Green open access is a slightly different model. So green open access means that you're typically publishing in a subscription journal. So the work will be behind a paywall. However, if the journal, has policies that comply with green open access policies, it means that some arbitrary length of time later, typically 6 or 12 months, you'll be able to publish the final accepted manuscript. So not the copy edited version, not the journal version, but the final version that was sort of submitted to the reviewers on a preprint server. And that will be kind of allowed within the policies of the journal. So the work, it's the final reviewed version will be allowed to be made available, but normally there is an embargo period of either 6 or 12 months. So that's kind of how the two models differ. So I think all the cell press journals probably have green open access compliant policies in place. And the open access journals, which are fully open access, are all gold models. In terms of editorial process, there shouldn't be any difference. Like a good journal is a good journal. So regardless of where, some journals are more optimized for speed. So the kind of Cell Reports journals, we try to be very, very fast, but that's not because we're an open access journal. That's because this is what we believe is important to our readers and our authors. Some of the other journals will be a little bit slower, probably because they may be asking the authors to do more. So, a very, very selective journal like Cell, the review process might simply take longer because the community demands more from a Cell paper than it does from a Cell Reports paper. So the editorial models are kind of orthogonal to the publishing model.
Yeah. Okay, thank you for that. So there's a question. This is regarding the research output in Cell journals that you just show, especially for Indonesia. So the question is, we've seen that the research output is not really that great, but the reason might be due to infamiliarity of publishers. So do you think anything that is this happen because we are not familiar, or is it happen because the rejection rate is very high? Or so which one do you think can contribute to this fact?
It's possibly a combination. So I like, for any paper that we assess, what we look at is, what is the bottom line of this paper? Is this interesting to our journal? Is it a point which is well made and which moves the field forward? We don't think, is this paper from country X or country Y? So the decisions aren't based on where the work is from. They're based on what the point of the work is and whether we think it's a good paper and whether we think it's advanced the field forward. So I don't know necessarily In fact, I know for sure that, there isn't a higher rejection rate simply because of the countries of authorship. However, largely what journals publish reflects what's submitted to them. So, my journal, I see about a third of our content comes from China, about a third of our content comes from the USA, and about a third of our content comes from the rest of the world. And this was the same when I was at Nature Communications. I mean, these are the kind of powerhouse researchers. And then within the rest of the world, it's dominated by countries like Germany, Netherlands, UK, Singapore, Japan, Korea. So I've, during my career, just not seen as much work from Malaysia, from Indonesia, pardon. So it might be that there's less familiarity with the publishers. Cell press is relatively new, certainly in the physical sciences. So we maybe not had so many submissions in those fields, and it might be the case that there's good work which is simply not being submitted. I mean, as I alluded to, the papers that had got in, all had decent field-weighted citation impacts. So there's certainly good work being produced in Indonesia, but it may be not the case that it's being submitted to cell press journals yet.
Mm. So if I can make a conclusion is, don't be afraid if you have it already.
Exactly.
Why not you try to publish in any self-press journals?
Mm-hmm.
Because again, quality, of course, will speak for itself. For citations and advancing the field and so on. Mm-hmm. So thank you. And there's a comment in the chat. I've done it. Okay. So the next question is about data. So sometimes data could be, let's say, a couple of years ago, and then the researchers then do experiments based on this data, and maybe the research itself could take like 1 year, 2 years, or even more than that. So do you think that it's still okay to publish these types of research, even though data might be a bit old?
Yeah, I think so. As long as the data hasn't been published anywhere else. I mean, it's well understood that a lot of data can take a long time to collect. So large biology studies where you have to grow colonies of mice, etc. So some experiments are very simple and can be done quickly, and some can take longer. So the age of the data doesn't really matter. The important thing is whether the data has been published somewhere else. So if the data's already been published, then yes, you've possibly missed your chance to publish it. However, if the data hasn't been published and it's just taken a long time to do the analysis or to get the paper written, and this is more prevalent than ever at the moment because of the pandemic, a lot of labs have been shut for 12 months. So I think age of data isn't a problem.
Okay, thank you for that. So the next one is about APC. So the researcher asked, the APC for one of the self-press collection is quite high, and there's a waiver policy, but Indonesia is not part of Research for Life country. And then to ask for waiver, we need to prove that we don't have enough funding. So can we like ask special conditions for this waiver for APC? No.
Yeah, I mean, I think you can always ask, and if you don't have funding and you want to publish in an appropriate journal, I think it's perfectly reasonable to ask. I can't say for certain that that the decision would be made to grant a waiver, but I think it's perfectly reasonable to ask if you don't have APC funding.
Okay. Now, the next one is this is a question regarding writing part. Should we mention the novelty of our research in the title of our article? Is it
so mentioning the novelty, I mean, I wouldn't use the word novel in a title. I think it's kind of a waste of a word. You can put better words. So I think it should be clear that your work is novel from the finding that you've made and sort of the bottom line argument that you're conveying. So no, I wouldn't recommend highlighting novelty in the title. I think if you found something interesting, the community will know that it's novel. If you're saying that it's novel, that normally detracts a little bit from the novelty. So no, I wouldn't recommend saying or highlighting novelty in the title. I would recommend saying very, very clearly what you've done. And if it is novel, the community will understand that it's novel.
Okay, thank you. So there's a researcher that just opened a Self-Press website, and she found out that Self-Press you have research journal, you have trend reviews journals, and also partner journals. So what's the difference between these three?
So the Cell Press journals are the journals that primarily focus research content and that are run by Cell Press professional editors. So this is, Cell, Chem, Joule, Matter, Cell Reports, Chem Catalysis, iScience. So while the different journals have different criteria for entry and require different, breadth of interest for the papers that they publish, they're all run by Cell Press, staffed by Cell Press editors, adhering to all the Cell Press policies and workflows, and publishing primarily research content, but also some review content. The Trends journals, also staffed by Cell Press editors, but publish only review content. So the Trends journals publish review papers. They don't publish primary research. So that's the difference between these two. And then the partner journals are run in collaboration with Cell Press, but normally with a partner organization. So possibly with a society, an academic society, occasionally with universities. And these journals typically won't be staffed by Cell Press editors. They'll adhere to a lot of the policies, but the people that run the journals and make the decisions on the papers will normally be academics associated with those institutions or societies.
Okay, yeah, okay, got it. Thank you. Now, the next question is, how can we avoid citing publications from a local region if the research topic is, let's say, about local culture or maybe local medicine? Yep.
I wouldn't suggest that you do avoid it. I would say, of course, in those cases, most of the citations will be local citations. I think it's a good idea, and it might be in some research areas that there are simply only citations from a local region, in which case that's all you can cite. Mm-hmm. However, more often than not, then research will be done in more than one geographical location. So I would make sure that, even if the majority of your citations are from one particular region, just make sure that you try to include citations from other regions as well to show the global nature of the endeavor.
Okay. Yeah, thank you. So is there any maximum numbers of percentage of self-citation?
As a rule, probably, there isn't we don't have a policy about the maximum number of self-citations, but I think editors and reviewers would probably start to notice if more than 20% of the citations were self-citations. So yeah, I would say, to be safe, you probably don't self-cite more than 20%. Okay. Because also, as I mentioned, if 80% of the citations are from your work, it suggests that no one else is interested. And, maybe the paper shouldn't be published if only your lab care about it. So you need to show that other groups are interested in the work to kind of demonstrate the breadth of interest that makes it worth publishing.
Okay. So the next question is about reviewers. So some journals will ask us to find reviewers. Do you think any best practices that you can share with us for finding the right reviewers? The journals that I've worked for, we typically wouldn't ask authors to find their own reviewers, but I know that some journals do. So if that's the case, I think try and think about people within the field that you think have a good understanding of the work, that you think can appreciate the complexities of what you're doing and the questions that you're addressing, and who have the correct technical expertise to assess the data that you've presented. So if you're using certain techniques, think about other researchers using those techniques. And then finally, really, you want to think about people who are likely to say yes. Because of course, you could, pick 3 or 4 people that have won Nobel Prizes that kind of are related, but these people probably are not going to say yes. So I think, depending on how exciting your research is, think about people at kind of appropriate levels in the research hierarchy that you think are likely to agree to review it. Okay, thank you. Another question is, you've shown the pyramid, and then there's a difference between the reader's perspective, author's perspective as well. So do you think that it's best for researchers to start with author's perspective or reader's perspective?
I don't think necessarily that you need to start with one or the other. I think you perhaps just need to bear in mind while writing your paper that the way you think about it will not perhaps be the same way that the authors think about it. Because obviously, if you're writing a paper, it might be that you're a grad student, and it might be that this is the first paper that you've written, and it might be a project that you've been working on for 3 years. And so you know the paper inside out. And for you, the most important sentences will be some small element of the results and discussion, because this is, you kind of laid everything out and you know it very, very clearly in your own mind. But most readers won't be anywhere near as familiar with the work as you are. So, you don't want to sort of bury these key points. So I think, important things to do are to consider how is a reader that doesn't know the field, or that knows the field and doesn't know this particular work, going to approach the paper. So I think whatever the key points are, make sure you really signpost those and make them very, very clear. And then finally, really my kind of one, again, like pro tip would be, don't write the abstract last. Write the abstract first. And it might be that the abstract changes as you write the paper, but every few days that you're working on your draft, revisit the abstract. Does the abstract still tell the story of the paper? And does the paper still tell the story of the abstracts? And, refine it as you write it. Don't just write it at the end as a last minute thing that you have to do before you submit. And similarly with the title. So think about the title. You might not know exactly what the title is at the beginning. You should know kind of what the story that you're telling is, and you can start to build the title. And then as you write the paper and you get feedback from the authors and from the other people that you show it to, you can refine the title.
Okay, I think that's a very good tips, because sometimes, yes, we researchers tend to put abstract at last minute. Maybe put like 10 minutes before submission. Yeah, so thank you for that. So this is specific for Self-Press. Do you guys accept pure experiment type of research? Yes, experiment.
Well, there has to be some kind of analysis around the research. So, if you've just done experiments for the sake of experiments, then no. But we don't need, not every research that we publish has to have computational or theoretical or techno-economic work associated with them. It might, so I handle some papers occasionally in condensed matter physics, and they're entirely experimental. They look at whatever thermal properties for a low-dimensional material. It's all experimental, but there is some explanation and some analysis of the work that is done. Similarly, we might publish work that's entirely computational, but again, there has to be some kind of link to the field. There has to be some analysis. It has to make a point, and it has to move the field forward. So whether it's computational, experimental, meta-analysis, that combination of all of the above, that's not really so important. What's important is that there's a clear finding, and then that finding has advanced the field.
Okay. Next one is there any impact of publishing only as a single author or with a team of authors?
Not really. I would say most high-level academic research these days, and I'm talking here about the very high-level stuff that we deal with at Self-Press or in my old job, it's quite difficult to do as a single author. So I think, most high-level academic research these days is collaborative, because there are, many techniques required. It's not to say that we don't publish single author work occasionally, but it's rare. So I think it's not that you will have a better chance of having your paper accepted if you're a large group rather than if you're a single author. However, if you're a single author, it's unlikely that you've been able to do the sort of very, very high-level research that highly selective journals are looking for.
Okay. Next question is about language editing service. Is it a must to always use language editing service before we publish?
No. So I would say try to get the work as legible as you can before you submit. And it might be that you have, collaborators either in your group or your institute or your university that you can get to look at the work for free. It might even be that you have some friends that aren't scientists but that have good English. I think the important thing is that the work is clear enough to get it, past the editor and for the reviewers to understand what's going on. If you want to, then one of the best ways that you can do that is using a language editing service. But I don't think there's any journals that I can think of that are good that would insist on this prior to submission.
Yeah.
Elsevier have some to offer. But again, there are also other ones available. So, and you can do it at any point during the process. So I occasionally have authors that, wait until they've got their paper through the review stage and they're up to just prior to the paper being accepted, and then they might use a language editing service. Or it might be that they use it in their revisions, like once it's clear that the paper's moving forward. And plenty of authors don't. So yeah, it's not a necessity. It can strengthen papers in some cases.
Okay. I think we still have time for 2 more questions. This is specific for your journal, Luke. So what's the average publication time for your journal?
So the average publication time from submission to acceptance, I think, is about 82 days. The average time from submission to first decision, so whether or not we send the paper out to review or we reject it, is about 2 days. And the average time from submission to first decision post review is about 28 days. So we are very fast.
That's
I mean,
fun.
because we're quite new, as the journal grows, I mean, I hope that we can stay that fast, but probably will become a little bit slower.
Yeah, but that's quite fast for such a good journal. Okay, so the last question is, this is specifically for physical science. So any best practices or any tips that you can share specific for physical science researchers, anything unique for physical science researchers that they really have to think through before they write or they publish their manuscript?
I mean, I think a lot of what I've said today is certainly relevant to physical sciences, but is also relevant to people in the life sciences as well. I mean, if I had to think of one tip, I would say a lot of the physical sciences papers are about how something performs. So about a thermoelectric device, or about a battery, or about a reaction in catalysis. I think the way that these metrics can be compared is perhaps simpler than it is in the life sciences or the health sciences. So if you've made a battery, you can say exactly what the capacity is, exactly, how many times you can charge it, and you can clearly compare that against the literature. So you can have a big table in your supplemental information where you get all the similar devices, and you say, this is how this one performs from this year. This is how this one performs from this year. Now, it might be that you've made the best ever battery. And so you can say, okay, mine performs better than all the rest. That's probably not the case. However, what you can do is you can contextualize the performance. So you can say, okay, this performs better than these other batteries according to this metric, but not as well as these other batteries according to this metric. And you can, try to understand why this is, and you can try to come up with strategies to improve the areas where it's less effective. So I think for physical sciences, often it's possible to be quantitative, and the more quantitative you can be, the sort of easier it is to put your work in the context of the literature. Even if it's not the best thing, you'll be able to say, okay, there are these things that are good about it. There are these things that are comparable to these other things.
Yep. Okay. Thank you for that, Luke. Actually, we still have 85 questions. So,
I mean, I have another 15 minutes or so. If people want to stay, I can do a little bit more. It's up to everybody else.
But the thing is, if we answer all of this, it will be until midnight time here. But again, thank you so much, Luke. We are sorry for all participants that maybe you have your questions not yet answered due to time limitations. But most of the questions already answered by Luke. So thank you so much for your session, and for your insight as well, and also for answering lots and lots of these questions from participants in Indonesia and also from outside Indonesia as well. So again, thank you so much, Luke, for sharing this. I hope we can see you again in another webinars, or possibly if you come to Jakarta. to Indonesia.
It would be delightful. I'd be happy to come to Jakarta and visit some Indonesian researchers.
We really have to travel, Luke. Okay, so again, thank you so much, Luke, and for also for participants for your attention, for asking questions. Yeah, we really hope that it's useful for your research, and for the publication. So for now, I'm going to share my screen again for post-event survey. And also, if you're wondering how to get certificate from this event, I'm going to share how you can get the certificate. Yeah. Okay, so let me share again. I think my colleague Sonam already shared the post-event survey as well. So we are really looking forward, for your input, for your feedback, to this session. So to do that, please do go to this link, or you can just scan the QR code, and then you will be directed to a page for the post-event survey. I've seen in chat that most of you already done this, so thank you so much for that. Please do let us know any topic, your feedback or any topics that you want for the next webinar. And for the next one is how you can also claim your certificate, for this specific webinar. And to do that, you can go to this link, or you can just scan the QR code. So again, you need to go to this link. It's bit.ly/ELCP21, or you can just scan the QR code. You will be directed to a page, and in that page, you will be asked to answer very simple, I think 5 or 6 questions, multiple choice questions. And after that, you will be directed to this page. So in this page, you need to put the workshop code, and the code is DATYEI. So that's the code. After you put the workshop code, then you will be able to download your certificate with your name. You might have to try this in a couple of times. If usually, because we have lots of, we have lots and lots of participants. Usually, if you go together to this website, it could crash. In that case, maybe you need to wait for another 10 or 15 minutes after the session ends, and then try again, to go here and then put in the code, and then you will be able to download your certificate. If you are asked to sign in, you will need to sign in first, using your Elsevier ID, because we need to know your first and last name. That's why we need you to sign in. After you sign in, then you will be able to download the certificate with your first and last name. Hopefully it's clear. And I think Sonam also already shared the information in the chat. So you can go to that link and you can use the passcode as well. We will send the information for the post-event survey, for the certificate, how to download certificate. We will send the recording and materials as well, to you after this session. So if you need look slide, this recording, all of the information, it will be sent to your email account, after this session. Okay. So again, thank you so much for everyone. Thank you so much, Luke, once again. And for all of the participants. Of course, this is just one of the so many series, so many webinars that we have done for Indonesia, and then there will be more. There will be more webinars coming very soon. Next month, we will have an outdoor workshop, and after that, we will have ebook workshops and